Write the electron configuration of several atoms in the periodic table. First of all, you need to draw on a scratch paper the orbitals that we need to follow when writing the electron configuration. So this is what we call the Aufbau principle. So if you are doing this in an exam, just start writing 1 to 7, 5, 6, 7, all the way, write S on it. And then skip the first line and start from the second and write P all the way down to 7. 7P. Now note that you need to be very organized and neat in your writing. Now 3D, 4, 5, and 6, and then 4F and 5F. Then after you write these numbers, you just draw parallel arrows going from right pointed downward left. Okay, so this is what the Aufbau diagram. This is the Aufbau principle, and this is the electron diagram, the way we write it. Now note that S can maximum hold 2 electrons, P can maximum hold 6, D 10, and F 14. So let's first start writing the electron configuration of calcium. So I'm going to place the diagram here next to me and follow it in writing the configuration. We have 20 electrons, so we need to distribute them. So the first arrow goes through 1s, so I write 1s2 because S can contain maximum 2. P6, D10, and F14. So after 1s, the arrow goes directly to 2s2. Note that you have to keep on adding the numbers of electrons in your head until you reach 20. This is where you stop. After 2s, the next arrow goes through 2p, and p can take up to 6 electrons. So far we filled 10 electrons out of 20. Now we continue. The arrow continues to 3s, so that is 3s2. Now we filled 12 electrons out of 20. Next, after 3s, the arrow goes to 3p. 3p can take up to 6. So if I filled 6 electrons, the total electrons filled now is 18 out of 20. So the next one is 4s. And I will put in it 4s2 because I need to fill 20 electrons. And this is the electron configuration of calcium. Now let's move on to another example. Write the electron configuration of phosphorus, and phosphorus has 15 electrons. So the arrow starts in 1s. So I write 1s2. So now we filled 2 electrons out of 15. 2 electrons. We continue. The arrow goes to 2s, and s can take 2 electrons. So that is now 4 electrons out of 15. After the 2s, we continue to 2p. That's 10 electrons out of 15. After the 2p6, we continue to 3s2. Now we filled 12 electrons out of 15. After 3s2, the arrow goes to 3p. Now if I put 3p6, that makes it 18 electrons. We don't want to reach the 18, so we do not put 6, we put less than 6. So after having our 12 electrons, we only need 3 in the p to fill 15 electrons. And here's the electron configuration of phosphorus. Now let's take another example. Nitrogen, 7 electrons. So the first orbital 1s2, the second 2s2. These are now 4 electrons out of 7 to fill. Now we need 3 more electrons to fill, and the next is 2p. So instead of writing 2p6, we are going to put 2p3. Adding 3 and 2 and 2, it is equal to 7 electrons. Another example, arsenic with 33 electrons. So let's start following the Aufbau principle diagram. So I have 33 electrons, so I'm gonna move on and fill the electrons in order until I reach almost here. I will start counting to see if I reach 33 or no. So 1s2, 2s2, I follow the arrows, now I'm here, 2p6, now I'm here, 3s2, next is 3p6, next is 4s2, and now 3d. As I mentioned at the beginning of this video, d can take up to 10. So let's pause and count now how many electrons we filled so far. 2 plus 2 equal 4, plus 6 equal 10, plus 2 equal 12, plus 6 equal 18, plus 2 equal 20, plus 10 equal 30 electrons so far out of 33 electrons. So we need 3 more electrons to fill. So after the 3d, so we're here, after the 3d, then I'm gonna move on to 4p. And I only need 3 electrons, so I'll write 4p3. The last example that I'm going to explain in this video is vanadium. So in vanadium, we have 23 electrons to fill. So again, if you look up, 20 electrons up till here. So I'm gonna copy this and then I will see how many electrons I'll put in the 3D. So 1s2, 2s2, I'm following the order. Next is 2p6, next is 3s2. Now we have 12 electrons filled so far. 3p6, that is 18. 4s2, 20 electrons. 20 electrons out of 23. So we have 23 electrons. After 4s, the arrow starts in 3d. So I'm gonna write 3d, 3. And that is the electron configuration of vanadium. Thank you.